Okay, here we go with a question which was put to me by a student. I'm 99% sure I've got this right. I'll be honest with you, there's a lot of work here for very little reward, but let's see if we can make a bit of sense of it. It's a bit of a trick here. So, as ever, please have a look, and then when you're ready to kind of think about and compare your solution to mine, press play. Okay, so I think the issue in this question comes from the setup. We've got monochromatic light traveling in glass and it's incident on the boundary. And we've got this idea here where we're at the critical angle. Okay, this is critical angle behavior. We've got angle of incidence and then a 90-degree angle of refraction. We're then told that we're going to put a layer of liquid on top, between the two. Okay, so we've got a layer of liquid on top of the glass without changing the angle of incidence. So we've got the same angle of incidence. The refractive index is greater, and we want to know what happens to the path of the light. All right, so you've got a few options there. We've got it bends towards the normal, goes straight through, etc., etc. Now, I think, to be honest, most students struggle between C and D. We're just not really sure what happens here. So I'm going to sort of dive into it in a lot of depth, which is probably unnecessary, so you don't have to. So let's go for it. Let's look at the first situation. Let's just think the first situation. We've got this glass, I've colored it blue, okay, and we've got a normal line. We've got our ray coming in and it's being refracted at 90 degrees. We've got an angle, I'm going to call that angle G, and then we've got an angle A. In this case, angle is 90. I've used G for glass, A for air. Okay, so it goes off there. We're going to then apply our Snell's law, which is N1 sine theta 1 equal N2 sine theta 2. In this case, I've used A and G for 1 and 2 respectively. So NG sine theta G, sine G, I'm not even used a theta here because I'm lazy, is equal to NA sine A. Now we hopefully all know that in this case we've got A equal to 90, that's sine of 90, that's 1. And we've got refractive index also equal to 1, so 1 times 1. NG sine G is equal to 1 times 1. So therefore NG sine G is equal to 1. We are going to need to use this later. Okay, so far so good. That's just the setup of the original problem. Basically what we're saying is that we multiply NG by sine of G, we get a 1, and that's fine for now. Let's then look at the new situation, and I'm just going to redraw it. We've now got a layer of liquid. I've colored that orange. Not sure what this is. Let's call it orange juice. I don't know. Okay, and we've got the air on top. We're then going to pass the same angle through. So we've got our ray coming in at G. Okay, and then we've got it refracting at an angle L. Okay, now let me just check that I've got this right. We're going slower. That's right. So we're going to bend away from the normal. That light is then going to pass through the layer of liquid to the air, and we need to think about the angles there. Now, because of maths, similar angles, I'm sorry, that's annoying that L's there, we have an angle of incidence here, which is equal to L. So if I know L here, I also know the L here. Because the Z angle is what we used to call it. I'm sure they have a different name now. That's then going to bend away again to an A, and I'm going to call that A dash. Now, A dash is the unknown new angle. We just don't know what it's doing, okay? So you see here that this could be this answer here, or it could be this answer here. We're bending away from normal because we're slowing down. Okay, now we're going to use some maths to try and prove one of the answers. We're going to start off by saying, well, let's ignore I'm going to put the cursor over here. NG sine G is going to be equal to NL sine L. Here, this is what I'm doing here, is I'm just looking at this bit of refraction here. NG sine G is equal to NL sine L. All right, because that's Stokes' law. Okay, sorry, Snell's law. We're just taking the angles there. Now, we know from the previous question, part of the question, that NG sine G is equal to 1. So these guys must multiply together to make 1. We've made no changes to NG, we've made no change to C, to the angle there, so they must be the same. So that's the refraction from glass to liquid. Now, from liquid to glass, we're going to do the same. We're going to have L's and A's. And we know that NL sine L is equal to NA sine A dash. And that also has to be equal to 1 because it's previously there. So it must be the case that sine A dash is equal to 1 over 1, which is equal to 1. In other words, A dash must be equal to 90 degrees, which gives us the same answer. All right, now, as I say, I think I've gone to far too much depth here. I don't know another way of doing it. Please do let me know if I've missed something really, really obvious. I love being pointed out that I'm overthinking these questions, and it seems to be a theme. Okay, but otherwise, I hope you've enjoyed that explanation, and let me know if you've got any questions.